translation of the high level languages like a compiler. So an interpreter is a program that read and executes code. So this includes source code, pre-compiled code and its script. It takes one statement of a high level language and translate it into a machine instruction which is immediately executed. So interpreter just translate a code into line by line, but a compiler translate the whole program at once. So interpreter and compiler are similar since they both recognize and process source code. So however, a compiler does not execute the code like an interpreter. Instead, a compiler simply converts the source code into machine code which can be run directly by the operating system as an executable program. So interpreter bypass the compilation process and execute the code directly. So this is the functioning of the interpreter. As interpreter read a source program and directly take data or machine and directly produce a result. This is the one line, translate one line and produce the result. This is the role of the interpreter. Next system program is the microprocessor. So as we know, I have explained, just to writing same repeated line in again and again in the program, we use a abbreviation. So this is used in the assembly language. A micro instruction, micro is a notational convenience for the programmer, so that will allow the programmer to write shorthand program like a modular programming. So just the microprocessor replaces each micro instruction with its equivalent block of instruction, and the microprocessor is not concerned with the meaning of involved statement during the expansion. So the design of microprocessor is like a we directive used, like a different directives are used like a LTORG equal start end. So these directly are the assembler directives, yeah, we can say that pseudops that provide operation to the assembler. So we start a definition with the micros and end this with the m end. So these two are the pseudops or are the assembler directives. So prototype, then we write a line of code that is we are going to abbreviated or make a micros for that. So each argument start with a name and micro and parameter list and then amend. The body statement will generated as the expansions of micro that we want to expand later on. So this is the a source program written in the assembly language or in the high level language with micro definition. So in the high level language, we write a micro definition with hash define, then name of micro, then the code that we want to replace. Suppose like we use a null equal to 0, null hash define, null 0 defined. So then any appearance of the null replace it with the 0. So then we have a microprocessor that will expanded these micro definitions and subroutines or call, and assembler will read these program without micros and produce a target. Next function is the same. So micros processor is only used for the, so for that we use a two micros, recursive or nested micros are used, conditional or recursive micros are used for the designing of the micro definition. So next system program is the linker. So as we know, linker is a system software that combine or link the various object module in order to. So when we write a program, we have a combination of different object module, like a different libraries are used, and to link these different object module or libraries, the linker is used. So why we cannot directly produce the code by the assembler or a compiler? The reason is that if we directly produce executable code without the help of linker, we need to load the assembler or compiler also into the main memory. So these are huge in the size. So for that, linker is, as per that, linker is a small program and the memory wastage is not done with the linker. So another reason if we any changes in the program on the later on, then we need to recompile or retranslate the program. So due to these disadvantages, by directly executing producing a executable code by the assembler or a compiler, we use a linker. So the two another function that also performed by the linker are the resolve external reference or program relocation. So during the process of combining object module, the linker relocate them since the code are generated by the compiler assembler, assuming the same fixed start address for all module. So another responsibility of the linker is to resolve or adjust external reference. So when a program consists of a large number of modules, a module may use a variable or a function which is defined in some other module. So another responsibility of the linker is to resolve or adjust. So resolve external reference means sometime a symbol or a variable is defined in a module that is not used in the another module. So during the process of compilation or assembling, so assembler will or compiler will read this as a external reference symbol. So these concept is also resolved by the linker, and another is the program relocation. Sometimes we during the execution we start a program from a different location. So later on when we load again a program, then location is the different. So for that sometime we use a constant literals or a size of module is as cannot change through if we load a program later on. So for that this function program relocation is also resolved by the linker. So during the process of combining object module, linker relocate them since or relocate those symbols that are not defined and code are generated by the compiler assembler assuming the same fixed start address for all the module. And another responsibility of the linker is to resolve or adjust external reference. So when a program consists of a large number of modules, one module may use a variable or function which is defined in some other module. So for program relocation concept, so as shown in the picture, so we have a different source file and different object file, and by using these runtime libraries, linker will link these different object module and finally produce a single executable code. That is, so next function when a linker links different object module, the next function is the loader. So loader basically a system software that will load a program into main memory and prepare them for execution. So the main four function of the loader that are provided by during the process of loading, first is the allocation, means providing space to the program into memory. So here memory is the main memory RAM of the computer system where program is going to be loaded. So loader will provide space to the program into the main memory. Then relocation means adjust all address dependent locations such as a address constants. If we have a constant starting address of the module, all these locations are relocated by the loader. Then link the various module by the adjusting symbolic reference, and finally load or place the physically instruction and data into the memory. So allocations or relocation, allocation is done by the programmer, or relocation and linking and loading are performed by the linker or loader. So this is the main function of the loader. Next system program is the editors. So text editor, a program that enable you to create, edit text files. There are many different type of editor, but they are fall into categories. Like a suppose we want to changes in a program or in a software, for that we use a editing facility. So later on we use a line editors, so line by line coded are edited. So nowadays we have a screen or cursor editor, by directly using graphical interface we can changes the program. So line editor are primitive form of editor that require you to specify specific line of text before you can make a change. So we need to define a lines that we want to edit, and screen editor with the help of cursors we can edit these or enable or modify the text. And as the word processor or editor, there is a distinction which is not clear cut. Word processor provide many more formatting feature. Nowadays the term editor usually refer to source code editor that include may specific feature for writing or editing the code. So next is a debugger that is used for to find or fix the bugs in a source program. A debugger allow programmer to stop a program at any point, examine and change the value of the variable. So for that editing purpose we use a debugger. So different debugging tool are used to test or debug other program. Debugging means locating bugs, fault in the program, and entire process of the program development error may be occur at various stages, and effort to detect and remove them may also made at various stage. So next or last system software is the operating system that is provide a interface between the user or hardware of a computer system, and the overall functionality of the computer system is controlled by the operating system. So we can say that it is a collection of software that manage computer hardware sources, hardware of the computer, and provide common service to the computer like a memory management, process management, interrupt management, securities. All these are overall total functionality are. So the main part of the operating system is the kernel, heart of the operating system. The operating system is an important component of system software in a programming. So some operating system come with a inbuilt editors, linkers, loaders and compiler. So application program usually required an operating system to perform. So for to run a application we need a operating system. So the operating system is the most important program run on a computer. So every general purpose computer must have a operating system to run other program. So operating system perform basic tasks, and these main functions of the operating system are the process management. So different processes are run on a computer system. For that, for a multi-user tasking, we operating system handle or provide a management of different processes. Main memory management, the main memory RAM of a computer system is managed by the also operating system. Secondary auxiliary storage devices are like a hard disk, tape drives, disk, all these are also handled by the operating system. File, different files are text file, where file we want to store, or the management is also by using a file, creating a file allocation table, and new technology NTFS file system also managed by the operating system. Input output devices management, different input output devices, peripheral devices are used. Protection and securities provide logs to a computer system. Networking, different protocols are inbuilt in the computer operating system, and command interpretation to run the different commands. So these are the main functionality of the operating system. So here is shown on the diagram like a management of the disk, application software, monitors, keyboards, printers, and all these are handled or controlled run by the operating system. So next is part of the our today topic is the compiler design process and different phases of the compiler. So as we know that a compiler translate high level language program into the machine language, and when so as we know that compiler is a language translator. When we open this box we have a division of total functionality of the process into a 7 phases, and these 7 we will discuss these 7 phases. So as we have already discussed, compilation is the translation of program written in a source language in the high level into systematically semantically equivalent program written in a target language. So as we know, compiler is also produce error message and produce a target code that is in the form of 0 or 1. So this is the interpreter, same function. So I directly produce executable code. So a compiler can translate an executable program in one language into a executable program in another language, or interpreter read an executable program, produce the result of running program. So the designing process of the compiler system program is divided into analysis, synthesis model of the compilation. Analysis are the means break up the source program into pieces and imposes a grammatical structure, whereas then create a intermediate representation of the source program, then determine the operation and record them in a tree structure like syntax tree and now. So in the diagram we will explain these steps, and this is a synthesis phase, later on phase of the compiler. So these are the tools are used in the like editors, pretty printers, static checkers, interpreted text formatters, silicon compilers. These are used with the during the analysis synthesis. So this is a language processing system. So first we have a source program that is not without the use of preprocessor or already included directories. So preprocessors produce a already processed code, source code, then compiler produce a target code with relocatable object code. The linker finally produce a relocatable, that are the temporary object code, and absolute means permanent machine code. So during this processes, when we open this box, so we have a compiler and divided into two major tasks: analysis of the source program, a synthesis phase of the program. So here is as shown in the total functionality. So this is the phases of the compiler. So we have a source program, and there are these are the phases of the compiler. So first phase of the compiler is the lexical analyzer, and then second is the syntax analyzer, semantic analyzer, intermediate code generation, code optimizer, and code generation. So with these different phases, we have a two informal formal phases. One is the symbol table management and error handler. So we start with the designing of the so first phase of the compiler is the lexical analyzer. This is act as a, we can say that a scanning of the, so lexical analyzer phase just read the sequence of character or string and divide into the tokens. So divided the source program into the smallest units that we call tokens. So token are the smallest unit that have some meaning. So and making these sequence of token called a lexeme. So we have a source program in the character stream or scanner. So then this is the lexical analyzer divided into the token. So next token is input to the next phase is the syntax analysis phase. So this phase check the syntax of the, so then suppose we have a this line, this structure of a compiler. So these the another token structure is a of is a token, A is a token, compiler is a token. So read these sequence, then check it is syntax wise correct. Then we have a semantic analysis that will indicating the meaning of the sequence of character. Mean what is actual the meaning, syntactic meaning. Then we have a intermediate representation in the form of parse tree or 3 address code, and based upon that we produce a code, assembled code, and finally produce a target code. Then as shown in the tokens are input to the parser. This is the syntax analysis. Another name of the syntax analysis is the parser. So scanner begin the analysis of the source program by reading the input character by character and grouping character into individual word or symbol that we call token. So then parser give a formal syntax specification, typically a context free grammar. So parse read token and group them into a unit as specified by the procedure of the context free grammar. So then semantic analysis check the meaning of the syntactic unit, then intermediate representation produce a optimized code, remove a redundant line of code, then code generated produce a target machine code. So we have a statement position equal to initial plus rate into start. So these identifier are stored in the symbol table with their value in the uniform symbol table. So position is a identifier. So first lexical analysis divided into token position into one token, assignment operator into log token, initial into different tokens plus rate star and size. So then when we divide these into token, then so this is the identifier, this is the assignment operator, this is also a identifier, arithmetic operator, identifier, multiplication, and this is the integer. So these are the token. Then parser produce a parse tree for that tokens. Then semantic check the meaning like a int into float, what is actual the meaning of that statement. Then code generated produce a 3 address code, like we have a temporary 1 variable where we can store 16, temporary 2 where we can store identifier and temp 1, then we have a temp 3 variable, then identifier. So temp 1 is added to the multiplied to the identifier 3, then temp 2 is added to the, and finally result is stored in the identifier 1. So based upon that we produce a optimized code like a temp 1 directly multiply into 16.0, and then finally then we produce a target code like a move that will finally produce a absolute code in the form of 0 1. So this is the total. So within that we have a symbol table management. If any error in any phases of the compilation process, the compiler produce this error. So in analysis phase, the compiling analysis has 3 phases. First is the lexical linear analysis, stream of character read from the left to right and group into the token, that is known as a lexical analysis, scanning of the program. Then hierarchical analysis, token grouped into hierarchically with collective meaning known as the parsing or syntax analysis. Then semantic analysis, checking if the program is component fit together, and output of these two produce a intermediate representation, and this intermediate representation later on used to produce a target code. So lexical analysis, so we have a, this is a statement. So what are the different token? So identifier position is a different token, the assignment symbol is different token, identifier initial plus sign, identifier rate, a multiplication sign, and number is a 60. So these are the division of the stream of character of stream into the form of token. Then syntax analysis, this is the parsing, and this phase dividing the token into the form of parse tree. So grouping into grammatical phases, character group according to the recorded in the symbol table like a assignment statement we have a, then we have a identifier position, then expression, there add, we have expression identifier initial, we have a expression multiplication, then we have a expression identifier rate, we have a expression number 16. So this is a parse tree for the position, assignment, initial plus rate into 16. So this is the parsing or designing of the different in output of the lexical analysis phase. Then hierarchical structure usually expressed by recursive rules, like a rule for definition of expression, and identifier is an expression and number is an expression. So this is two different expression performing the operations. So check semantic means what is actually the meaning. Suppose I write a int I, so what is, so that will reserve a 2 byte space of with name I. I is the variable where value of I is varying. So check source program for semantic errors, so that will gather type information for subsequent code generation, like a type checking, identify operator and operand of expression and statement. So these are the different phases of the compiler. So here is a source program written in the high level language. So lexical analyzer divided these sequence of source code into the form of tokens. Then syntax tree read these token produced by the lexical analysis and produce a parse tree. Then semantic analysis check the meaning of that, what is actual the meaning. Then intermediate code generation produce a intermediate representation, and code optimize produce a optimized code, and finally code generation produce a target code with a absolute address and information for the loader, linker or loader. And with these different phases we have a two other phases, symbol table manager and a error handler. So symbol table record all the identifier or symbol used in the program throughout the life, and error handler produce the error message at any phases. So symbol table is a data structure with record for each identifier and its attribute, and attribute includes, and it have a two storage type and scope of the variable. So intermediate code generation produce a representation of abstract machine, should have two property, easy to produce and translate into target code. So for that we use a 3 address code. And code optimization produce a improve intermediate code by producing code that run faster, and code generation produce a which is machine code and code. So these are the different phases of the compiler. So first phase, program source code produce a source string, that is a statement. So these are the tokens A, assignment B plus C, and termination, colon, semicolon, and this is the parse tree of that statement. So this is the intermediate representation of that code, and this is the optimized form of 3 address code, and this is the finally assembled code, machine code. So that will produce a object code. So this is the grouping of the phases into front end and back end. So front end are the analysis step and intermediate code, and depend primarily on the source language, machine independent. Back end are the code optimization and generation, independent of source language, machine dependent. And with grouping of phases we have a single pass or multi pass compiler. So single pass are used for the reading a processing a output by large compile program, usually run faster, and multi pass split the function into the overall functionality. So for compiler construction we use a inbuilt tool like a scanner, parser, lexical analyzer, lex, or yet another compiler for parser. So this is the review of the today lecture. So today we have explained with different software, system software, or just introduction of the different assembler, compiler, linkers, loader, microprocessor, operating system, editor, debugger, and different phases of the system program compiler, and introduction of the different. So in the design procedure we have discussed the 7 phases of the compiler and explanation of what is the functioning of each of the phases. So this is the review of today lecture. Any queries? Thank you.